Hello everyone, welcome to this video where we'll introduce the different primitive data types and where we'll also introduce the different operators that we can use in Java. In previous videos, we've already introduced Boolean, int, and double as primitive data types. These data types are the only types in Java that are not based on classes, in contrast to our airplane class, for example. As such, they don't have behaviors or methods. They're used to store a single value of the given type. Java provides us with 8 primitive data types. 4 of them are for integer values, which are byte, short, int, and long. 2 of them for floating point values that you can use for decimal values, which are float and double. 1 data type for storing single characters, for example the letter A or a comma, which is called char, and Boolean for storing true and false flags. As we see here, for integer and decimal values, we have more than 1 data type available. The reason to have multiple types in those cases is to have types that have different sizes in memory. In general, for integer values, you will be using int and long, and for decimal values, you will be using double. You might come across use cases where you need to use the other data types. So what do we mean by the sizes in memory? As we mentioned before, when we declare a variable, a space in memory is reserved to store its value. Different types occupy a different amount of space in memory. For example, the data type byte, as you would expect, occupies 1 single byte in memory. And we can use it to store values ranging from -128 to 127. Now, the same happens with other data types. We're going to write down in this video the sizes and/or the standards that apply to some of these types, but we won't go into the details of some of these at this stage. We will provide additional links if you want to read more about these topics and standards. What I want us to focus on are the differences between the data types and to understand that different data types can be used to store different ranges of values. And that depending on the use case that you have at hand, you will choose an appropriate type. Okay, so let's see this in code. For this video, I have a starter project with a main class and an empty main method. We also have the airplane class, which we're going to use towards the end of the video. So let's see a few examples in Java of these different data types. As we've seen in previous videos, we can define int to store integer values. So for example, we can do int a equals 1. And the compiler is going to generate an error if we, for example, try to assign a decimal value to it. Let's say we try to assign 1.5 instead of 1. In this case, we're going to get a compiler error saying that the data types are not as expected. Now, if we would like to store that 1.5, we should use an appropriate data type for decimal values. For example, double. I can do double b equals 1.5, and in this case, I don't get any compiler error. Okay, let's try a smaller data type for integers, like byte. Let's define byte d equals 200, and in this case, the compiler is going to indicate that there is an error. Basically because 200 is outside the range that byte can store. So let's do byte d equals 20. In the char data type, we can store a single character. As we said before, for example, the letter A. So we can define char e equals A, for example. In Java, we identify single characters using a single quote, like this. And now let's define a Boolean flag. So we can do Boolean flag equals true, which is a data type that we've used in previous videos as a field inside our airplane class. Booleans allow only two values, either true or false. As you can see, when we use primitive data types, we don't need to use the new operator, like with our airplane class. Primitive data types are special types built into Java, and they're not objects as such. When we assign them a fixed value, like we're doing in these examples, all these values are called literals. It is important to note that for long literal values, we need to add an L to the end of the number. Otherwise, the compiler will treat it as an int value. For example, if we do long L equal 10 billion, like this, the compiler is going to show us an error because it thinks that 10 billion is an int number, which is outside the range of values for an int. So if I add an L to the end, it identifies it as a long. One thing that I wanted to note here is that we can use the underscores to separate the digits. This is only for readability purposes. The number is the same with and without the underscores, of course, so I can do this as well. But it's a little bit more difficult to read, so I'm gonna add them back, and that's it. Okay, now besides long literal values, we also need to do something similar for float values. For example, if we set float f equals 1.5, we're also gonna get a compiler error because Java sees the 1.5 as a double value. Now, if we add f at the end, the compiler error will go away because Java recognizes this literal as a float value. Just a quick note, if you're developing a system that requires precise decimal values, you shouldn't use either double nor float. Java provides classes that are meant to use for this purpose, for example, the big decimal class, but that's outside the scope of this video. I just wanted to give you a quick note on that. Now, this topic lends itself to an additional data type where Java provides a special support, and that's character strings. You provide strings as sequences of characters inside double quotes, and we've used them in previous videos. These, however, are not a primitive type. These are supported by the string class in Java. So we'll use a string as the type of a variable, for example, a string message equals, and in double quotes, the word hello. As you can see, we haven't imported the string class and we don't get any compilation errors. This is because the string class comes from the java.lang package, and hence we don't need to import it. And part of the special support that Java provides for strings is that we don't need to use the new operator. Behind the scenes, when we provide a literal string, like our hello example, Java will automatically assign a string object. Now, a string is a class as such, so it means that it also provides methods that we can use. For example, we can find out the length of our string by using the length method, like this. I can provide int len equals message.length. The string class provides several methods, which we are not going to cover in this video. However, you can take a look at the Java documentation to find out more about this class. Now, the second topic that we're going to cover in this video relates to the operators that you can use to perform operation on these data types. Please note that we won't cover all of them here, but the ones that you will most commonly see when starting to develop in Java. The first of them is the assignment operator, which we've already used before. For example, when we assign a new value to a variable, like a equals 2, the assignment operator is represented by the single equal sign, and assigns the value on the right-hand side of the operator to the variable that is on the left-hand side. The next set of operators relates to arithmetic operations, and in general they follow the symbols used in mathematics. As we've seen before in a couple of videos, we can use addition using the plus sign, like a equals 2 plus 1, and multiplication using the star sign, for example, a equals 2 times b. As you would expect, we can also use the minus sign for subtraction, like a equals a minus 1, for example, and the forward slash sign for division, so we can use, let's say, a equals d divided 2. Of course, in Java, you can compound expressions or join them together, for example. We can do a equals 2 times a plus d minus 1. And in these cases, it is always recommended to use parentheses to group the expressions to clarify the order in which they need to be executed. Same as you would do in mathematics, for example. It is not the same a equals 2 times d plus 1 than a equals 2 times, and in parentheses, d plus 1. They have different results. Now, there are three things to note in arithmetic operators that might be new to you. First is that you can use the percent symbol, like a equals a percent 2, to get the remainder of a division. And the percent symbol is the remainder operator. Second is that you can mix arithmetic operators and the assignment operator to create what are called compound assignment operators to simplify some code. For example, if I type a plus equals 1, this is exactly the same as typing a equals a plus 1. So I'm changing the value of the variable a and increasing it by 1. And we can do similar things, for example, with the multiplication, subtraction, and other symbols. So I can do a times equals d, which would be equivalent to a equals a times d. Now the third thing is that there is a special case when using the plus sign, and it's when you're using it with the string objects. In Java, same as in other programming languages, you can concatenate strings using the plus sign. For example, I'm going to remove all of this for the moment. For example, we can do a string s1 equals hello and a string s2 equals world. And we can concatenate the two strings into a new object using the plus sign. For example, message equals s1 plus s2. And we can print out that message. So I can do system.out.println and I can print the message. And in this case, if we run the code, we get hello world as the string object. Excellent. So that covers the arithmetic operations that involve more than one operand. Now, for numeric and character values, you can also use unary increment and decrement operators. So, for example, I'm going to remove all of this. We can do a++ to increment the value of a by 1. And also we can do a minus minus to decrement its value by 1. It is important to note that these unary operators have two versions. You can use them as a postfix, like we're doing here, a++, or also as a prefix, you can do ++a. Using this prefix or postfix version affects when the change of the value of variable is going to take place when you mix it with other operations. And I know it sounds confusing, so let's see an example of that. So let's mix the unary operator in the same statement with an assignment operator. So I'm going to remove this code for the moment. And let's assume that you have int value equals 0. And let's use the prefix version and assign the result to a new variable. So we're going to mix both operations in the same statement. So I can do int result equals plus plus value. And let's print out both variables to the console. So I'm going to do system.out.println. I'm going to do value equals, that's value. And I'm going to do the same with the result. Result equals. And let's run the program. As you can see, when using the prefix version, the change of value of the value variable is taking place before the assignment operation is executed. So in this case, the result variable sees the incremented value of 1. Now let's change it to using the postfix version. So let's change it to value plus plus and run the program again. In this case, you can see that the increment of the variable takes place after the assignment. So the result variable sees the value before the increment, so it is equal to 0. The last unary operator we're going to see for numerical values in this video is the minus unary operator. And it is used to negate an expression. So for example, if we change value to be 1 and set result to be minus value, if we run the program, then of course value is going to be 1 and result is going to be minus 1. Similarly, if we set the value to be minus 1, the result would be positive 1. There is a similar unary operator for Boolean values, denoted by an exclamation mark, which returns true if a Boolean value is false and false if the value is true. So for example, let's delete this code and we're going to have Boolean value equals true and Boolean result equals exclamation mark value. When we run the code, we should get true and false as expected. Now, there are operators that can be used on other types besides numerical operators that help us check for equality. This is to check if a variable is equal or not to another value or variable. In Java, you can check for equality using the equals to operator, which is denoted by double equals, and the not equals operator, which is denoted by an exclamation mark and an equal sign. Do bear in mind that the equals to operator is a double equal sign and shouldn't be confused with assignment operator that is represented by a single equal sign. These operators return a Boolean value indicating true or false as the result of the operation. So for example, if we have two variables int x equals 1, let's delete this code as well, and int y equals 1, and we check for equality, so I'm adding parentheses for clarity, so I'm doing x equals y, which is basically, I'm asking Java if x has the same value as y. And if we print out the result, so let's do system.out.println for r equal, and we run the code. Of course, we get true in this case because both have the same value, both have the value of 1. Now, if we check for inequality and use the not equal sign, then the result that we're going to get in this case is false. So besides the equality operators, when we are comparing numerical values, we can also use relational operators to check if a value is greater than another value, for example. So we can do a Boolean result equals is x greater than y, for example, and print out that result. In this case, of course, x has the same value as 1, so it's not greater than y. So x has the same value as y, so we get false as the result. We can also use greater or equal than, and in this case we're going to get true because it's greater or equal, so we get true. And we can do the same in the reverse order, so we can do less than, so I can ask Java if x is less than y, or if x is less or equal than y. So if I run this code again, it's going to tell me true. X is less or equal than 1, in this case both are equal, so we get true. Now, before we move to the conditional operators, there is an important note that we need to make on the equality operators that we just saw. When we use reference variables, let's say we create two airplane objects. So let's create plane 1, and let's create plane 2, and assign a different object to each of them. We can also compare them for equality. So for example, check if plane 1 is equal to plane 2. And I'm going to print out are plane 1 and plane 2 equal. And let's add a breakpoint in the line with the equality check and run the code in debug mode. Now the caveat, or the thing that I want to point out, is the following. If we check both plane objects, plane 1 and plane 2, they both have the same state, right? So they have the same ID of 0, and they have the same value for the landed flag. So arguably, the two objects are the same, and we would expect our equality check to return true. So let's step over in the debugger, and we'll see that the r equal variable, when we compare the airplanes, or well, the plane 1 and plane 2 variables, it tells me that they're not equal. It tells me that r equal is false. What is happening here is that in Java, the equality operator, these double equals, when you use them with reference variables like plane 1 and plane 2, it returns true only if both variables are referencing the same object. In our case, plane 1 is referencing a different airplane object than plane 2 because we used the new airplane expression in both of them, so they're separate objects. And that's the reason why the equality checks returns false. So I'm going to stop the debugger for a second, and if on the other hand we set plane 2 to be equals to plane 1, and we run the code again, well, in this case, we get that yes, both of them are pointing to the same object, so Java tells us that it's true, both references are the same. In Java, if you want to check for object equality, you should use the equals method. However, that's outside of the scope of this video. Lastly, we're going to cover the conditional operators that are used when working with Boolean expressions. In some cases, you will have Boolean flags, and you will need to check, for example, if at least one of the two flags is true, or if both are true. So I'm going to delete this code. Let's assume that you're working in an amusement park, and you're asked to verify if a person is at least 18 years old, and that their height is above 160 centimeters, to let them ride a particular roller coaster. Let's say that we're given an age of 18 and a height of the person in centimeters of 170. And that we have two Boolean flags. We have one Boolean flag to check for the age. So check if the age is greater or equal than 18. And also a height check to check if the height in centimeters is greater than 160. Those are the two conditions that we were told. Now, in this case, as we need to verify that both Boolean values are true, you can use the conditional AND operator, which is represented by a double ampersand sign, as follows. So we can do Boolean check equals age check and height check. And we're going to print the results. So we're going to say, hey, is the person 18 or over and over 160 centimeters? So we're going to get a true or false value here. So remember that the AND operator is only going to return true when both operands, in this case the age check and the height check, are true. So if we run our code, we will get true in this case because both Boolean values are true. Our age is greater or equal than 18, our height in centimeters is greater than 160. Now let's assume that our age is 17. And let's add a breakpoint in the line where we define our check variable and run the code in debug mode. In this case, of course, our age check is false because, well, 17 is not greater or equal than 18, and our height check is true. Now, the reason that I wanted to run the code in debug mode in this case is to highlight what is called short-circuiting. In this particular case, our first operand, which is the age check, is false. When you use the AND operator, the double ampersand, because it only returns true if both values are true, Java is not going to check the second operand at all if it sees that the first operand is false. So internally, Java is not even going to read the value of the height check in this line of code because age check is already false, and it already knows that the result of this operation is going to be false. So it short circuits the operation and stops there and returns the value of false in this case. So if I step over, we can see that the check is false. Okay, now let's assume that the rules are slightly different for the purpose of the example. Let's assume that only one of the two conditions must be true to let people ride the roller coaster. So in this case, we can use the OR operator, which is denoted by a double pipe. So our check is now going to become, instead of using the double ampersand, it's going to become the double pipe, and that's the OR operator. And the OR operator, in contrast to the AND operator, only returns false if both operands are false. In any other case, it will return true. So let's run our code, and in this case, our height check is true, so we should get true. Now let's change our age to be 18 again, and let's run the code in debug mode again. So similarly to the AND operator, the OR operator is also a short circuit operator. In this case, because the first operand, in this case age check, is true, Java knows that the result is going to be true. Remember that for the OR operator, it's only false when both of them are false. So internally, in this case, Java is not even going to read the value of the height check because it already knows what the result is going to be, so it returns true straight away. Okay, so we covered a lot of topics in this video. To recap, we introduced the different primitive types in Java, and we also introduced the string type. We saw the different operators that we can apply to different types of values, including arithmetic, assignment, equality, and relational operators. And we saw a few corner cases, like the object reference equality and the short-circuiting in some of these operators. Please note that there are a few other operators available that we didn't cover in this video, namely the bitwise and bitshift operations, for example, that were outside of the scope of this video. And that's it for now. We hope you found it useful. Thanks for watching, everyone.